important for our before lunch stuff. Okay, so finding Riemann sums, we could use a left Riemann sum we learned last time and a right Riemann sum. And my touch screen isn't working. Hide. Now my touch screen is working. Okay, so we could use a left Riemann sum, right Riemann sum, but there's two more types of Riemann sums. There's the midpoint Riemann sum and the trapezoidal Riemann sum. Okay, the midpoint Riemann sum is actually a little bit more accurate than the left or right Riemann sum because it takes a value in the middle of each. So if we had from 1 to 4 of this function, and we're told to use a Riemann sum for the midpoint sum, we go to 1.5 and make a rectangle. At 2.5, we go up and make a rectangle. And at 3.5, we go up and make a rectangle. And let me do this and this. Dang it. Come on. Come back. And like this. I hate when it does that. It has a mind of its own. Try it one more time. And then I'll go here. VTI. So I have my graphic calculator up. Boom, boom. There it is. Okay, so if we're doing this Riemann sum, I have to put 1.5 in for x to figure out the height, because my width is going to be 1 for each of these of my rectangle. My height is going to be whatever 1.5, 2.5, and 3.5 squared is. So I'm going to go 1.5 squared, and then 1.5 squared is 2.25 times 1 is just going to be 2.25. So I'm just going to go 1.5 squared plus 2.5 squared plus 3.5 squared for this one. Okay? And so the area of all these rectangles added up is 20.75. Okay? Which is fairly close to the area all under the curve, because the extra from here you can put over here, the extra from here you can put over here, and the extra from here you can put over here, and it's going to be pretty close. A lot closer than a left Riemann sum or a right Riemann sum would be. Okay? So that's a midpoint sum. You go in the middle of your area, you go up until you hit the line, and so on. Do you got a slip? Well, you kind of are absent, you know, or tardy or whatever. All right. A trapezoidal sum is you're going to make a trapezoid out of this. Okay? So from -4 to 2, there's 6. From -4 to 2 is a difference of 6, and you want 3 equal subdivisions. So you're going to make a trapezoid like this, a trapezoid like this, and a trapezoid like, that's not so good, like this. Okay? And you're going to find the area of each of those trapezoids. Well, how do you find the area of a trapezoid? Well, it's 1/2 the height times base 1 plus base 2. It's right over there. Okay, so this first trapezoid over here is 1/2. The height is the different distance between the two parallel sides. So the height on each of these is going to be 2. Base 1, the distance of base 1, the length of base 1 here is 2. The length of base 2 here is 6. And then the next trapezoid is going to be 1/2 of 2 times 6 plus, because this is 6, this one is 3. plus 1/2 of 2 times, this distance is 3, this distance is 5. Well, what's 1/2 of 2? 1. So it's 1 times 8 and 1 times 9 and 1 times 8. So it's 8 plus 9 plus 8, which is 25. That's the estimated area under the curve. What we lose there, we gain there. Okay, so a little more accurate than left and right Riemann's sums. Okay, here's another trapezoidal sum. Okay, so we're having 3 equal subdivisions, and I cut off the bottom, and I shouldn't have done that because this is 0.5, 1, 1.5, and 2. So between 0.5 and 2, each of these is 1/2. So if I draw my trapezoids in here, okay, so we go 1/2 times the distance in between the bases, which is 1/2 times the length of this base. What's 2 divided by 1/2? 4, plus, what's 2 divided by 1? 2, plus 1/2 times 1/2 times 2 plus, what's 2 divided by 1.5? Well, it's 1.3 repeating, which is the same as 4/3. So then we take plus 1/2 times 1/2, 1/2, the distance between the two bases, and then the base 1, 4/3, plus 2 divided by 2 is 1. Okay? So I'm going to type that into the calculator, but I'm going to combine these as 1/4. I'm just going to make each of these 1/4. So it's going to be 1/4 times 6 plus 1/4 times 2 plus 4/3 plus 1/4 times 4/3 plus 1. It equals, and it's that, and it's go, well, what is that? Well, if we go math, turn it into a fraction, please, we get 35/12, which is the answer. Okay? Now, would that be an overestimate or an underestimate? Would this be an overestimate or an underestimate? Overestimate, because the actual curve slides underneath that line just slightly. Okay? We talked about overestimates and underestimates last time. Here's a trapezoidal sum where we don't even have a graph. How do we figure this out? Well, the x distance is our height, so we go 1/2 of 3 times, and then these are our two distances, or two base lengths, 8 plus 6, plus 1/2 of 3 times 6 plus 3, plus 1/2 of 3 times 3 plus 4. Okay? So it's 0.5 times 3 times 14 plus 0.5 times 3 times 9 plus 0.5 times 3 times 7, which ends up to be 45. Okay? Area under the curve using Riemann sums or trapezoidals or midpoint ones. Okay, our next thing is summation notation. We'll get really into summation notation after lunch. But summation notation, we have the index, which tells me what number we're going to put in for the function for that letter. And we're going to say how far we go on that index, and we count by ones. as we do it. So if we have n equals 1 of 4n, where 6 is our last number, we take 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5 plus 4 times 6, which winds up to be 84. You can handle that, right? So if n equals 1, so it'd be k over 1 plus 1 plus k over 1, 2 plus 1 plus k over 3 plus 1 plus k over 4 plus 1. Once you hit this number, you stop. Okay? So which one would be the appropriate answer for this? It would be A. Okay? Summation notation. Which summation notation would give us 2 plus 5 plus 8 plus 11 with this first one? If we stick in a 1, what do we get?
2.
If we stick in a 2, what do we get?
5.
3,
8.
4.
11.
Okay, this one works. Let's see if this one works. If we stick in a 0, what do we get?
2.
If we stick in a 1,
5.
2,
8.
and 11. Both of these happen to work. Okay? Let's look at this one. Woo, we got I's and J's in. Does this have anything to do with I?
I think that's a J. So
That's a J.
okay.
That's a J, sorry. That's a J. So, does that have anything to do with I? No, so we don't plug anything in for I. So we leave it as I. So it's 2 times I times 1 plus 8 times 1 squared. Okay? So basically it's 2i plus 8 squared plus 2 times I times 2, or 4i, plus, if we stick a 2 in here, 2 times 8 is 16 squared, plus, and so on and so on and so forth. Okay, which one is that?
C.
C. This sum, which gives us that sum? Does the top one? So it's 9 minus 4, which is 5. 9 minus 16, which is negative 7. 9 minus 36, which is negative 27, and so on. So the first one works. Does the second one work? Two plus 3 is 5. 3 minus 2 is 1, which is 5. 4 plus 3 is 7. 3 minus 4 is negative 1. So negative 1 times 7 is negative 7. 2 times 3 is 6. Plus 3 is 9. And then if we take 3 minus 6, it's negative 3. 9 times negative 3 is negative 27. Both of these work.